Hello, everyone. My name is Ron Petty, and welcome to ChatLoopBackOff. Today, we're going to take a look at Headlamp, learn about it, see how to use it, and embarrass myself along the way. So, this is ChatLoopBackOff. We follow the CNCF Code of Conduct. So, don't add anything in the chat that would be offensive and play by the rules. So, let's go ahead and get started. All right. So, I am new to Headlamp. Part of this show is to actually be caught off guard, and it is pretty easy to get caught off guard in the cloud native space. There's so many things out there. So what I want to do is, set some goals here. First goal is to have a hello world understanding of what Headlamp is. What is it supposed to do? Kind of the second goal might be not just know what it does, but actually do it, right? And then maybe a third step is how to do basic modifications to the system itself. Whatever it is that it's supposed to be doing. And so I do have familiarity with Kubernetes. Always learning, but have been using it for quite a while. So we'll be looking for things like how does it integrate with Kubernetes? Is it the kind of typical resource interactions? Is it something a little bit more advanced, like an operator? Is it something maybe outside of Kubernetes that looks into the cluster? Or maybe we'll be surprised and it has nothing to do with Kubernetes, and this was all a joke to begin with. Kubernetes isn't the only thing that's cloud native in this world, so maybe it has something to do with something I've never seen before. Okay, so I'm going to go ahead and share my screen and see what Google has to say about Headlamp, and who knows, maybe we'll ask ChatGPT along the way and see what it thinks. So let me share my screen here. All right, share screen. We'll just go ahead and do the entire screen. Okay. So hopefully you can see my Chrome here. And what I'm going to do is just look up Headlamp, and let's just see what Google has to say about this. I'm going to say Kubernetes just to make sure there's not more than one spelunking Headlamp. All right, so your Kubernetes experience. Headlamp is a user-friendly Kubernetes UI focused on extensibility. All right, so it appears to be a user controller of somehow. Oh, unexpected. It's a Mac app and maybe others. Looks like a nice visual tool. There are text-based user interfaces for Kubernetes, of course. This one appears to be graphical. Adaptable UI and branding, create custom experiences. RBAC controls, so presumably we can limit who can see what based on who they are. And can be desktop and web. All right. See some ways to install this. All right, so there's the desktop app. Generally, I try to avoid all desktop apps as best I can. So we're going to see what else we got. We have in cluster. So this is definitely more in line with what I would have expected. Okay, so we got Helm install, YAML install, Minikube, Docker, ships as a Docker extension. All right. I would not put this as an in-cluster thing, but maybe it is. Maybe it still goes behind into the VM on your Mac or Windows machine and actually still installs the manifest. But that's what we're going to do. Let's go ahead without further ado and take a look at this. All right, so that's an icon. I don't know what that means. That says copy. What is this? Toggle word wrap. Well, that's extreme. All right, let's copy. Okay, so we didn't do this here, but just for the record, I'll go ahead and show I've installed Kubernetes on a VM at Amazon. So this is a pretty vanilla installer. I just want to show, so in case anyone has Any questions, and I'll share the link after the show here or in the chat if I can go find the link again. But basically, we're picking a particular version of Kubernetes, and then we're going to use Weave for now. We're actually probably should use Calico, but Weave for now because it still works. And then redirect to use a container D, right? So remember, if you install Docker, it comes with Docker Engine and then container D. And now we want to, the CRI interface is to container D from Kubernetes. So that's the configuration there. And then the rest of this is actually just installing Kubernetes itself. So getting the app repos set up and using kubeadm pointing to container D. So this is arguably very vanilla install of Kubernetes, and this is what I've done. And then ultimately we can prove this works, just to kind of show what's going on here. And not much is happening, right? We got Kubernetes running, and that's about it. Okay, so there's our environment. No trickery here. Again, this is Amazon EC2 on Ubuntu. Let me zoom in. Maybe that would be kinder to people. This is on Ubuntu, in this case, 2204. Okay, and if you really want to get crazy, there's the kernel. Okay, so let's take a look at that YAML. So again, let's copy this link. Never run anything you download off the internet, even if it's going to go into a container in a pod. So let's just take a look at the kinds of things this has in it. So let's one thing I like to do before I do anything is just see what constitutes the components, at least at a Kubernetes resource level. So let's grep kind. Oops, didn't work. Let me guess. This is typo. It is lowercase, of course. Grep kind. Let's get rid of that curl timer. All right, not too bad. It's just a service and a deployment and a secret. That's pretty basic, which is kind of what I would expect from something like a user interface. There may be other things like config maps to store configuration, right? So it's not out of the ballpark of what I would expect. Let's just see how many lines are in here. So 53, so it's very small. So let's just go ahead and take a look at it. All right, so the service, for those who are new to Kubernetes, service again is just going to give us a nice DNS to a virtual load balancer inside the cluster, of course. And then here we have a deployment, which is what the service will be pointing to, right? In this case, the main target right here is this guy, Headlamp latest. All right, so that's a little risky, having latest, right? Always pulling the latest versus locked down to a particular version. So that's something we may want to recommend to the Headlamp folks. Again, the URL might be presuming the latest, but maybe tie it down to particular versions of the latest, or SHA, of course. Okay, it looks like it's loading some plugins, so we need to learn out what those things are. Be interesting to find out if this is required or not, because just as a general statement for any kind of tools, I prefer tools that do the default thing out of the box, right? You shouldn't need any arguments. It should just be, if it was a binary, I should just be able to type Headlamp and it should just do something useful, right? Maybe it's just printing the help menu, but or could do a hello world experience. I shouldn't have to read anything. That's not knocking Headlamp. This is just a general thing. Less is more, right? So presumably the in cluster here is because of the different installation methods it needs to know, I suppose, that it's in a cluster. There might be other ways, but this is, I guess, the kind of pedantic way to say that I'm in the cluster. So presumably on the computer, it would be I'm in or on the computer, right? And again, we'll see what the plugins might mean later. All right, again, we're targeting 4466. That's good. So we don't have to be root again under port 80. So that's nice. Okay, node selector, OS Linux. Have to double check. That'll probably work. I don't remember all my labels off the top of my head, but hopefully that works out of the box as well. And then here's a secret to mount a token. Okay, so is that actually right? Yeah, type account token. So this is creating a service. Presumably there will be a service account called Headlamp admin somewhere that's created. Presumably the deployment will do that. And then we'll see. Let's just see how this goes. There's probably more instructions. All right, let's just let it rip and see what happens. kubectl. Actually, you know what? Let's download it so we could actually modify it just in case we need to. All right, headlamp YAML. Okay, and let's just actually one last check. Let's see. Was there anything about namespaces, service and kube system? Okay, kube system. All right, let's good to know. Wouldn't normally put it there, but let's see what it does. Okay. Let's see. Let's get pods. Can we watch all? Yeah. Oh, it's already running. Okay, that was quick. For those who don't know what I just did, what I wanted to do was so a deployment will create the pod, and it could take some time. But here it seems to be quite fast. So not only did it download the image and run it, it's already rocking and rolling here, right? So again, it's in Kube system. Let's take a look at its logs. So Kube system logs, and then we want pod. Oh my gosh, sorry, headlamp. Yes. Okay. What does it look like? So written in Go, not unexpected. And loading kube config. Okay. Interesting. And then no such directory, message loading dynamic kube config. All right. So it's looking for some kind of access controls or config to presumably do some kind of access. Okay, let's take a look at its. Again, I don't like looking at documentation to start because it jades my. Or maybe jades the wrong word. I like to actually use basic computer science to see what something is doing before I get influenced by what the authors of the tool may do. So, at this point now I want to look at its IP, see if I can do basic things like curl to it, take a look at the presumably HTTP app based on the service, see what kind of headers and things are there, right? All right, so again, let's just get the pods. If we do wide, we can get their IP addresses. 2 rules of Kubernetes networking, right? Pods can talk to pods and nodes can talk to pods. So we can, since we're on a node, we're a node of 1, right? I didn't actually point that out. I should maybe show that. We're just a single node here. What we want is, let's just grab headlamp. Okay, there is its IP address. And again, if we take a look at the YAML, we see that it was listening on 4466. So let's see what happens here. All right, we got HTML back. So that presumably means it's a web server. It's not something tricking us. There's JavaScript. You need to enable JavaScript, right? All right. So this looks promising. Next is can't really use the service directly because we want to see presumably a user interface, and this clearly does not look like a textual interface. So let's just jump back here just real quick. Showing a lot of text, but the overall system here is not a text-based system. So as expected, we have to expose. So that's something to consider, right? This right here won't work out of the box, right? It did install it, did open up a port, but nonetheless, we can't access it because we don't have a node port in this particular case. All right, so for those who don't know what a node port is basically a way of exposing an inner service to the outside world, right? So we want our EC2 box to open up a port that will then forward traffic to this service here. And so there's a couple of ways to do that. And if I can remember correctly, I think we can look at the label, or well, let's look at the names of the services here. So we have a headlamp service, and I think one way to do this is expose, let's see, service, not Kubernetes. We want to do headlamp. And then here we want to do node port, which I think it would be type probably. Yeah, type. And there it is, node port. So yeah, let's do node port. Type node port. And then we need to target the service port. So let's, again, just to remind ourselves what that was. The service itself is actually listening on 80, right? And here, just to kind of prove that, we could do 101, 20, 14. 14 is 104. Be pedantic, we'll say 80. And there it is. So remember, again, 2 rules of Kubernetes networking. Generally speaking, doesn't matter the tech that you use. Pods can talk to pods, meaning over the network, and nodes can talk to pods, and also in this case, the cluster IPs as well. What you may not get is things like DNS, right? The pods have internal DNS, but not external, right? And so on and so forth. So you have to set that stuff up yourself. Okay, so we know it's on port 80. So let's do that target port on port 80. Okay. And then a node port will be random, right? And so the node port is a range in Linux. Not sure about Windows, but a range, whatever, 30,000 to 32,000. Generally, it'll randomly pick one in there and expose that on the host. And if it's taken, it will pick another one, right? And so that's effectively what a node port is. And then we also, just by how this works, when you create a node port, another cluster IP will be picked in its port. All right, if I remember my details correct here. So let's just let's see what it does without it. I can't remember, so let's find out. All right, wrong namespace. All right, so in this case, we want the cube system. Oh yeah, we need to. Oh, sorry. This is the name of what we're calling it. So this will be. We'll just say MP for node port, and then what we need to do is what is the word for the service that we're targeting? I cannot remember how this is done. Could look it up, but that would be no fun, right? Doobie 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 doo. The name for the newly created object. Okay. Oh man, how embarrassing. I forgot how this is done. All right, let's just see. Here we go. Expose. Type name. Yes. Target port. Name external. I guess we just have to target the port. Okay. Maybe that's all we need to do. All right. Change that name again. What? All right. Let's just cheat. All right. Let's just cheat. All right. Expose node port service kubectl. Doobadoo. Oh, you know what? Let's double cheat here. Let's do a kubectl expose node port. Oh, the name was the targeted service. All right. So it must default to it. All right, so we'll do node port, and then name is Headlamp. What? No, I have this backwards. Name MP. DNS must consist of lowercase. MP. Hey, all right. Basics kill you, right? Okay, so let's see what port we got. Get service, and then here we have this guy. So there's our port. So if all goes well, we should be able to just curl the local machine on that port and get the same thing. And it's denied. Is this because of labels? Did I not? It's not magically just going to do that. Get endpoints for Headlamp NP. Cube system. What? Okay. That is the right IP, and it is on the endpoint. So what was the error here? Failed to connect. 31981. All right, let's try the host IP. How do you do that? Hostname -I. So, yeah, there we go. Hostname -I. I need this guy again. 31981. Curl hostname -I. What? Double check. Oh, wrong port. Actually, hold on. Get services. What are you on? Didn't we say Headlamp is on this guy? And then what is that? The pods? The pod IP. Okay. Oh, it's the pod, but the pod is not on port 80. Oh, I guess it doesn't indirect through the service. I can't. Sorry. All right, let's get rid of the service and use the port of the pod. I think that will fix this. All right. Delete service, cube system, and lamp node port. Okay. And then if we expose again, I guess misunderstood target port. I thought it would go to the service, but it goes to the pods. Which here, now I just went blank. What was the pods? What was the, not 4466. There we go. That's what I think we need. 4466. Okay. Curl. Oops. Well, yeah, let's just 4466. Okay. Get services. All right. We want to try that again. Let's try the no port. Hey, all right. We're cooking now. Okay. So just to confuse matters, this is on EC2, and I am using the non-static external IP address. So for those who don't know much about Amazon networking, at least out of the box, when you create an EC2 instance, you get some local IPs like this, right? So 172.3.1.17.15. This is the IP in their network, right? So it's denatted, right? So the external IP that we need to use is not this. There's different ways to do this. You can see it here. It's a little hard to see, but 3, 128, 189, 19. That is the external IP. So you get that in their portal. Another trick is, and I always forget the command, get external IP from terminal EC2, right? So just look up EC2. And then here, there's a couple different ways to do it. So like here's the kind of built-in tooling. I don't know if this comes with here. Yeah, you got to install it. There's actually a simpler way. So there's a NAT capture. Oops, that didn't work either. Let's see. Sorry. More than one way to do this without belaboring the point. This is the one I always use. I was just checking if the other ones work. So this here matches the external IP, right? So this here, last I checked, is actually still not documented properly or even officially supported, but it has worked for years and years and years. So that's the IP we want to use. And again, we want to use the node port 32.7. So let's go ahead and construct this here so we can actually just copy and paste this one time. Right? In fact, we should be able to run it from here unless there's some kind of trickery going on, interfering. Yep. All right, there we go. Next is put it in our browser. All right, Headlamp, come to life. All right. Paste your authentication token. Check out how to generate a service account token. Okay, let's see if it's got good docs. But actually, I want to check the chat here. How we doing? Sorry, I couldn't see the chat as we're doing it because I was full screen. Maybe I'll slide it over. In fact, let me try that right now just to see if I can. I don't know if that'll annoy people if they can see their own chat here. All right, are you Bill X inside the pod? Hi, hello from India. Hello from San Francisco. It is the 4th of July. If you can see my board behind us, tried to draw some fireworks. Does Headlamp must it be deployed in the case control plane? I'm going to guess not. That's something we should try, right? Now, let's just go ahead and see if we can log in, right? Let's figure out this token part, and then let's blow it away and move it out of the Cube system namespace and see if it still just works without much trickery, right? Okay. So good questions. All right. So again, what we're trying to do now is let's see how can log in here. How to generate a token. Let's see what it says. It's probably going to take us to there docs. All right. Nice looking documentation. Nice and clean. Not too much fluff. I like that. It did link down to the bottom, but let's see. Headlamp can be deployed in case cluster or as a desktop app. So we've we've done the first. Currently, you can log into Headlamp by using a client certificate or a bearer token. So for those who, real quick, who aren't aware of what those things are, a cert is a piece of paper, as it were, that you present to that can be used in turn to authenticate who you are. So you look at it and you can think there's pieces of information in a cert, like typically what's known as a common name or CN, and that would be like my name, Ron, right? And so the cert itself generally lives somewhere, so systems can look at it and inspect it, right? And as you present related information, it'll check and see if you were found inside of it or not. A bearer token, we'll just keep it simple for now, is just a string that gets generated by a system and can be verified. And again, it's the creator of the system is generally trusted or is trusted, and thus that token is trusted until it expires. All right. So how do we do these things? So here, a service account token. What is this? Kubernetes has a notion of I'm simplifying a little. Two users. There's kind of external users to the system, and then there's service accounts, which are kind of internal to the system. Users are managed outside of Kubernetes typically, or very closely through cert management directly in the cluster. And then a service account is basically its user account manager. Its service accounts, again, are software when they do the talking, right? So we can have certs for service accounts. We can have tokens for service accounts. And in this case, it's saying we should have, we're going to do a token. All right, so first is create that service account. So if you remember in the YAML, there was nothing there, right? There was a service, there was a deployment. Actually, sorry, I may have just misspoke. Let's take one last look here. There was a secret. Okay, so there actually was one created. All right, so that's a little confusing because it's telling us to go create one, yet there is one right here that's created. Right, so notice the name, Headlamp admin. All right, and so if I say kubectl get secret, and in this case it's in the kube system namespace, right? This is, the name is Headlamp admin. Where is it? Namespace kube system. It's no, that's right. It's a little weird. So this is not it. This is used by kubeadm when I created the cluster. This should have been created. So that's a little weird. Why is it? Should be in kube system. Should be called Headlamp admin. That is. Let's see if we can go back far enough. Sorry for the jump in here. All right. I'm just looking for where we actually ran it. Okay, so here we downloaded it. Take a look. Grep kind, curl, and then here we go. All right, secret Headlamp admin. Okay, looks like it should have been there. All right, my hunch is that it actually created it because it showed that it created it, and then maybe Headlamp deleted it. Maybe it was a temporary thing it used for itself during the deployment. So that's something. Don't want to oversell what I think's going on, but that does seem a little. Sorry. Oh, I get it. I'm sorry. I am wrong. It's a holiday here. My brain is slow. I'm sorry. There should be a secret, but the secret is missing. So I'm not sure what's going on there. But what this is actually saying is create a service account. So just to prove we don't have that service account, let's take a look at that. Too many close enough acronyms. Kube system. Then get service accounts. Okay, so let's see, grep admin. All right, so this is not there, and again, it was not in the YAML. Okay, so that's what this is telling us to do right here. So create a service account. So again, a service account is, think of it like again, for those who are newer to Kubernetes, this is a user, but for your system, right? These are what your software running in pods get to use to authenticate, versus say kubectl, where we're the external users and we're using our certs and token systems outside of Kubernetes. I mean, those systems could live in Kubernetes as well, but you manage the users. Okay. All right, there it is. All right, so we just take a quick look here for those who are new, just to maybe see what this looks like. Describe service account, headlamp, admin. All right, and so one thing to notice here is we don't have a token, right? And that's one of the things it was saying we could do. So we can create a secret with effectively an annotation where it ties back to this service account, and it will create the token for us. Okay. All right. So creating the service account token. So we have the service account. Next is the permissions. So in this case, it says create cluster role binding headlamp admin service account. So this is the service account we just created. Notice it's namespaced by the namespace. It's namespaced. There it is again, headlamp admin. That's this guy right here. And then, unfortunately, I hate it when this happens. The little things here are over it. So it says cluster role. Here, let's just call it cluster role admin. So let's just take a look at this. Comment it out so we don't accidentally run it. And so, again, just to explain what's going on here. So this is saying create a new role binding. For those who don't know what a cluster role binding is, or just a role binding, these are basically a map. These are things that are going to point to a config file, which has permissions to do things. And then that's one side of it. And then it's mapping it to users or service accounts or groups, right? Which is another listing of things, right? So in this case, we'll give it this mapping, we give it a name. Cluster, what that means is it's for all namespaces. Okay, so it's for all namespaces, not just one. Role binding does a mapping and gives you permissions in a singular namespace, like default or kube system. This, presumably this is a UI, right? So we want to see all the things in all the namespaces, right? With this account. Okay, there's that service account we just created. And then here, this is a pre-made, presumably, role. So role binding, the name kind of explains it, right? We're binding to a role. And in this case, there's different roles in cluster roles, right? Roles would go to a namespace. Uh-oh, I just lost my internet. What just happened? Or lost SSH. Oh, we're back. Let me check, make sure you're still here. All right. I think we're still here. Looks good to me. Okay. All right. So again, what we were trying to do is all right. So what we want to do, just for those who are new, is kind of take a look at this. So this is the part that we created. We're mapping. We're taking permissions on, we'll just say the left side, and mapping it to users or service accounts on the right side. So presumably this cluster role already exists. So let's prove that. And let's just get, because these are cluster wide, you don't need to specify a namespace. So get cluster. Oops. Let's enable autocomplete. So there's autocomplete. So kubectl get cluster role, and then we want the name cluster admin, and there it is. So let's describe it and see what kind of things it can do real quick. Describe. Okay. Not very interesting. It looks like you can do everything. Right, so this kind of makes sense, right? You're a cluster admin. Now this may not look obvious to you because this doesn't look like YAML, but the verb here are the key, right? Asterisk means all the verbs: get, put, post, delete, patch, right? All those things. And then the resources here are wildcarded as well, so all of them. Now, what's the difference between, why are there two rows? Just real quick, just be aware that there's resources in Kubernetes, right? We're talking about pods, deployments, services, right? The kind of things, right? But there's also URLs that don't manifest as resources, right? Like slash metrics, slash version, right? Those kinds of things. So if you are unfamiliar with URLs in Kubernetes, one way to see these things is with the -v option. So if I do, just as a quick aside here, get pod, um, right? And so we see the pod, or there's no pods in this case, but it still does a REST call. So in this case, what we can do is um, do -v, which makes it more verbose. And there's 9 levels. So I'm just going to cut to 4. Still nothing. Go to 5. Go to 6. And now we start to see. So the higher you go up to 9, the more details you get. And so you can see right here, there's a URL. So it's always a URL behind the scenes, but some of these things are not resources. Now, in the case of pods, that's a resource. If I go one more, level 7, we get more information, right? We're starting to see request headers now, right? Not just the URL that's the verb that's attempted, right? You can see responses, short and sweet, 200. Let's go to 8. Right now, we start to see all the headers and the actual content coming back as JSON, right? And then just to go all the way, there's 9, which just blah, right? Too much. So anyway, those are again going back to why were we talking about this? Is just remember that there's resources, which are the things in Kubernetes, and then there's the API server has other endpoints, right, that don't represent Kubernetes things. We can see this as YAML, of course, which is also maybe easier on the eyes for those who are newer, right? And so you can see right here, right? There's API groups. And so this is basically saying, give us all permissions. Okay, so let's just do what they say. And this looks reasonable for now in my test cluster, maybe not in a real production system. Okay, and now there's a role binding. And again, this is the mapping of those two things, right? If we take a look at that cluster role bindings, there's a bunch of them. We can just say, oops, I meant grep lamp. Bring it back up. And there it is, right? Sorry, I'll make this full screen again. There's the name of our role binding, and then it gives us a little information. And here we can see the headers. Let's go ahead and get the headers here as well. All right, so what we're seeing is the name, the role that we're interested in, and then you go into the bindings to see who it's mapped to. Okay. Next is create the token. Okay. So here, the token, again, is what's going to be used. We will put it in the user interface, but then ultimately that's passed in presumably as a bearer token through HTTP, which we should be able to see through snooping the network. Okay, so create the token using the following command. Let's just go ahead and do this. In fact, let's take a... So it says here, create token, right? So presumably you would see that there are tokens. So this is one of those examples of a non-resource in Kubernetes, right? So behind the scenes, in fact, if we, again, just do something like this. Oh, it's in fact, it doesn't even attempt, or does it? Yeah, it fails. All right, well, all right, let's not get too crazy. But again, this is it's a non-normal resource. All right, so let's create it. Okay, there is our token. Okay, now let's see what it says for us to do. Otherwise, run the command, the following command to get the token associated with the account. Once you have the service account token, paste it in Headlamp. All right, OIDC, for those who don't know what this is Open ID Connect, I think is what it stands for. So this is when maybe you'll use like Keycloak, right? Or SSO systems, right? So somebody else is creating tokens and managing tokens or certs, right? So that's how you do it here. All right, so it says here we just need to copy it. This seems a little out of place. There is no following command here, so I'm not sure what this is referring to. So this looks like unless they're saying this is the command, just formatted a little odd. All right, let's take this whole thing, and are we in? Hopefully, no one's looking over our shoulders because that would be very unauthenticated. Beautiful. All right, a round of applause for Headlamp. It's up. It's alive. That was pretty straightforward. All right, let me see the time here. Let's see. Any new questions in time? Okay, I believe we have. 15 minutes left. 14 minutes left. Is there any questions before we poke around real quick here? Any questions? Okay, let's keep going. Right. Now we could read the instructions and see what Headlamp's about, or we can just click on buttons and see what happens, right? Okay, so cluster main. Not sure what main is, but presumably that's our cluster. Typically speaking, that might be something like this: kubectl config view. What do we? Oops, let's do autocomplete again. Let's do kubectl config view cluster. Is that how you do this? Config view. No. All right. Apparently, I don't know how to do that. All right. So we have a cluster called Kubernetes, right? So having it being called main is confusing to me. There is no main cluster. All right. So that's just something to point out. And again, their documentation may say something to that effect. We'll take a look in a moment. Okay. Namespaces. Those are the namespaces. We'll go deeper in a moment. We're just poking around here. Do you have one node? That looks reasonable. No CRDs. Again, for CRDs, just to kind of prove that point, get CRDs. Let's look in all namespaces. No CRDs found. So that looks good to me. Okay, workloads. This is an overused term, unfortunately, but generally speaking, it means what are you running, right? Some people think of it as individual things like a pod. Others treat the word as a whole SaaS, right? It's everything that goes together. So it's a very non-deterministic word, but for us, we'll just go with what are you running in general. All right, so we got deployments, pods. This all looks nice and neat. I do like the format. Let's see, can we download this as a CSV? The Excel user in me is screaming. No, I don't see a way, at least not right here. That would be a nice thing maybe to have. Okay, let's just take a look at a couple of these pods. Nicely formatted. Restarts. This is all nice information. Doesn't scroll left or right. This here is the wide view or a wide view. Let's just confirm that. So let's take a look at the pods. So pods, we'll look at all of them and then we'll say wide. Okay, so we have namespace, name, ready, status, namespace, ready, status, restarts. There's restarts, so it's a little different ordering here. Age IP, there's age, there's our IP, and there's the node. We don't have nominated node. That's okay. We don't have ready case. That's okay generally to ignore for most people. Okay, so it's a summary of that information. So this looks good. It is a little bit different ordering. I wonder if we could move things around. Clear, sort, filters. What about dragging? Can we drag? No. Okay. For me, the only comment there is I'm used to seeing, I do things in the command line as much as I can. This does look very nice though. So if the ordering changes, that throws my simple mind off a little bit, but not that big of a problem. Okay, deployments. Let's see. pause it. This all looks similar as well. Actually, let's take a look for deployments, just as another example. Again, just comparing the types of information we see. All right, so for deployments, we have name, ready, update. We have containers, right? Images, selectors. So the image is shown, right? And then containers. Okay, we have similar information. Okay, storage. What do we got here? So PVCs. And I was going to say, where's the PVs? There's the PVs. That makes sense. Storage class. This looks nice. Okay, network. What do we see here? Services. Okay, endpoints, ingresses. All right, these are all very standard components. This is very nice. Looks very nice. Security. All right, service accounts. How is this? Just curious how this is ordered out of the box. This is by time, I guess. By age. I guess that makes sense. We want to know if people are creating accounts immediately. So like that, to me, like that would be a nice thing to know. Like I shouldn't have to read any docs. There should be like a little thing that says this is the default. And maybe that's what this icon is. Maybe I guess that is what that's showing us. Okay. All right. I regress what I undo what I just said. That actually is reasonable. Okay. Very good. Here's the roles and roles bindings. Okay, so notice here they've commingled roles and cluster roles versus having them separate over here. I think that's okay. Just something to note as we use the tool. Okay, configuration. What do we see here? Config maps. Okay. Secrets. Okay. Horizontal scalars, empty. Vertical scalars. Don't see cluster auto scalars, but that's okay because even though we're in the cloud, we're not using EKS in this case of Amazon. PDPs or Bs. This is how many, if you're running out of resources and priorities, which of the replicas do you get rid of? That's what this information is. All right, so this all looks good. There is a create button that seems to transcend all of these down at the bottom. Events is empty here. That's only warnings. Let's see. Can we? Oh, there we go. All right. That looks reasonable. Okay, let's dive all the way down into a pod real quick just to see like how far we can go here. We'll just pick Headlamp itself. Learn more about enabling advanced charts. Oh, this button needs to be a different color, but let's see where it goes. Plugins, Prometheus. Okay, that's cool. So we can notice we're in the Headlamp repo. So we could install Prometheus. And then that, for those who don't know Prometheus, will pull in metrics. And then as you can kind of get the hint here, would show it. So that's very nice. I don't think this should take up the entire real estate if you don't have it, though. This should be shrunk down, I would say. Let's see, what are these? Show logs, terminal exec, attach, edit. Those are good. Good basic control information, scheduling information. Okay, so this is all things we can see from the command line tool, nicely rendered. I do like this. It's very crisp looking for sure. Let's take a look at some of these other things. Oh, so it's a pop-up style. Okay. Can we copy and paste? Looks like we can. Let's just see what that looks like. Actually, let's do this. Yep, pasted nicely. Okay. Yeah, so there's previous container. So this is if your container restarts, you would lose the logs. So in this case, we Kubernetes will copy the logs elsewhere so we can see, if it's see what the prior failure was. Okay. Nice. We can get rid of timestamps. Following is following the logs here. Kind of interesting that we don't see anything happening though. Oh, if refresh gets rid of it, that's a bummer. Is there a refresh button here? I believe following's working, but again, if in fact, well, I don't want to get too tricky here. I was going to say we could go inject stuff and see it work, but let's not derail in the last minutes here. Okay, let's do an exec. See if this works. All right, we do get a shell. All right, let's see what we got. OS release. So we're in Alpine. Ooh, I never really learned what is APK. Is that the tool? Yeah. Let's see, APK add curl, permission denied. Okay, so some controls here around what we can do. All right, there we can see Headlamp running. Again, I believe it's a Go-based program. So there we go with all the settings. All right, looks pretty good. All right, we only have a couple minutes here. Let me go back to the chat. Okay, nothing in the chat. All right, looks like we're going to run out of time to go crazy on this. But going back to the docs, let me stop. Well, actually, let's go back to the docs before we stop here. Seems pretty easy. Looks very nice. Kudos to Headlamp. It's very pleasing, easy on the eyes. My only immediate thing might be is to be able to export into CSVs. Maybe there was an option and I just missed it. And then maybe a secondary thing is that Prometheus plugin screen is taking up half the real estate. So, shrink that down so we could actually see things without being pinged for what we didn't do. But aside that, Headlamp looks very, very promising. More things to consider: RBAC controls, right? Those are things that it had mentioned. Trying it on your desktop, right? That's another thing to use. Now, we didn't do it locally, but the use of that bear token seems that it would perfectly be reasonable to work externally. So if we had an external app connecting to an internal cluster, that seems normal. We are using HTTP, if I remember correctly. Where'd it go? Yeah. So, this is they change these warnings so often. So I guess this is HTTP, not HTTPS. Okay. So that is Headlamp. We'll go ahead and end it here. Thank you everybody for attending. Again, hello from our friends in India. It's very, very late there, and that's always rough. Hopefully this gives you a hello world into Headlamp, and you can enjoy more adventures from there.